So if you've heard of it before, if you know anything about it, you knew too much already, as far as I'm concerned. Okay, ElasticSearch. Okay, so it's a search engine. So it's a tool for searching information stored in some sort of database. It's a front end to another to the real search engine, which is called Lucene, Lucene, however you want to pronounce it. You can have it over. It can be distributed over multiple servers, so you can use it for lots and lots of data, and it's quite fast retrieval. It can handle lots of transactions simultaneously, and it's a so-called NoSQL database, so it doesn't operate like classic databases that you probably used to, like Oracle maybe, or I don't know, MariaDB, or Microsoft SQL. It has an HTTP interface to use to communicate with it programmatically. And there's also dedicated application programming interfaces for several common programming languages. For example, Kuha uses Perl. And it has a built-in redundancy for in case if you distribute over multiple servers and you have failure in one server, it will not bring the system down. It can continue working. And this stuff is very easy to set up. A little bit about Lucene. It's a search engine written by a fellow called Doug. Yeah, okay. Sorry.
Thank you.
Hello?
Perfect.
Lucene. It's a search engine written by a guy called Doug Cutting about 10 years ago. He used a language called Java, and it was his 5th search engine that he wrote. So he was getting pretty good at it. It was adopted by the Apache Software Foundation, so it's open source. That means you can go in and you can get the code and you can change it if you want. And it's been ported to several languages, which means that it'll operate natively in on several virtual machines, or you can compile it. For example, C++ is a compiled language, and I think that's what ElasticSearch uses, the version that it uses, because it would be quite fast. And it allows for full text searching, so you can search for text within a block of text, like a word within a block of text. Just a bit of terminology. The chunks of information are stored in things called documents. If you're used to a standard database, these would be a bit like a record. So for an example, if you had a ElasticSearch index, they're called indexes, full of say films, then you'd have one document per film. And within the document, you have a number of fields. You can have variable numbers of fields, even in the same index. And for our example, that would be like the title of the film, a producer, a summary, or any other any way you want to break down information about the film. Each of the fields are searchable. And you can choose if they're searchable or not. The default is that they're searchable when you index something just from scratch. And of course, they're indexed, which means they're put in a form so they can be information within them can be quickly found. I just wanted to show you an open source inspection tool for ElasticSearch called Head. And Kevin's going to show it here. So this is our ElasticSearch cluster that we use here for Kuha and other things. So what we have, Kuha consists of two indexes. One is for the authorities. there's authorities, and there's also bibliographic information. The bibliographic information is extracted from the MARC records in Kuha, and as well, some item information is added to those. These little colored names here are called aliases. They're just a way of talking to various, an easy way of talking to, pointing out a particular index for Kuha, for example. So we can work on one and be using another one while we're building one or something. So this is a tool that you can use to see what's in your data, in your index. This is an overview showing all the different indexes. We have them for test and different things. There's a tab here called Browser, and here we see a list of just a summary of records. Here's all the fields that Kuha uses. There's quite a few of them. And if we just, these are authorities. We just click on Biblio here. Oops. Yeah, so there's bibliographic, and we just do one like this. And then this is the information for a particular bibliographic item. So it seems to be in a strange, I guess that's
Russian.
Yeah, Russian or something. So the one that we're using an older version of Kuha, 1805, I believe. 1711, sorry. So the MARC record is embedded directly into the index. So this is a MARC record for you people who are familiar with MARC records. There's tag 01, the indicators, I guess they're called, and the data. For example, yeah. And there's also here the 952 field, or tag, contains item information. So this is information stored about. These are subfields, like subfield 1 contains a 0. I can't remember what that means. I guess it means the item was lost, I think. If it's 1, it was lost. If it's 0, it's not lost.
So you're checking one item from one indexation or something?
Yeah,
like
this
that?
is a document I'm looking at here.
Oh.
Okay,
Yeah,
and these are all the fields.
For each item, there's a 952.
So you can have multiple 952s for a particular MARC field. Okay. That's just an example of what you can use to look at the raw data in case you need to. A bit about indexing. Indexing is important because it's how you store the data is key to how fast you can retrieve it, and you want to retrieve it quickly. It uses, oh, sorry. Just text. Second. Okay. Yeah. The ElasticSearch uses something called a tokenizer to transform the text in a document to a form that's normalized. So, for example, in English, it would remove the endings of verbs. For example, running would be transformed into run, and ran would be probably transformed to run as well, or perhaps not. It's irregular, but plurals would be removed, things like that. It also removes articles, like small words that don't really have much meaning in the text. So that, for example, in English, the, in, and in Swedish. This is controllable through the API, and you can add new ones that you want to remove, or you can leave them in there. So when you do a search, they will become, your query will look for them. So these are language-based. You typically have a tokenizer per language. Kuha, in fact, uses a generalized European language tokenizer, but they are available in different languages. I'm not sure if there's a Swedish one per se. I know there's English and there's Chinese and some of these more exotic languages that don't tokenize the same way European languages do. So what you can also have in a document, you can have, like some of the documents here, like for example, you can have titles in Swedish and English, if they've been translated, for example. And in that case, you can use different tokenizers for different languages. So per field, they can be used, which will give you better search results. Kuha doesn't do that, but it sounds like something that might be useful. The matching, when you issue a query to ElasticSearch, it's tokenized. It uses the same tokenizer to break it down into these components. And then these components are matched using a very simple algorithm that just compares characters and words. So there's nothing exotic about it. There is a form of fuzzy matching that ElasticSearch supports that could be used to match the inexact matches. I don't believe we use that in Kuha. You can control, when you talk about relevance, so if you do a search and you get a list of books, for example, documents, the ones that are presented first are the ones that are weighted highest based on a built-in weighting system. And this weighting system can be changed if you don't like the way Kuha is, or ElasticSearch is weighting your results. For example, if you're a store and you're using ElasticSearch to let people find products, you want them to find the products that they're looking for, but you also want them to find the products that you want to get rid of maybe, or the products that are more expensive. So you would go in and you would adjust these parameters so that the relevance, to change the relevance of what they see first on the first page, or sorted order. And just a bit more specific stuff about how ElasticSearch is using Kuha. There's an older, the original, I guess, search engine called Zebra, which you might have heard of. It's still available, as far as I know. We've never used it, but it's the one that people have been using until very recently. I know that the 1905 is definitely the first version of Kuha with a working ElasticSearch. In our older version that we started off with, it wasn't fully working, but it was there. I believe ElasticSearch comes in several versions. They're putting out new versions almost yearly. Kuha used, I think it's using version 5 now, but they're working to bring it up to 6. Yes, and there were the 2 indexes that I showed you, and a bit about the other information. So ElasticSearch is given away freely by a company called Elastic, and they have other products. And one of their inspection tools called Kibana, which Kevin has here. Show us. So this is looking at our Kuha's bibliographic record using Kibana. It has a different format. The fields are a bit more compact. You can use this to go in there and check various things if you're wondering how it looks. There's other features. I'm afraid to press these buttons here. Visualize what's this. You can create a dashboard, they call it, where you can have various graphical graphs, I guess, like pie charts and stuff, and hook them up to the data quite fairly simply and display how many lost books you have, for example, or break it down: lost books, damaged books, stuff like that. So we haven't used it yet for that, but yeah, you have to start by creating the stuff. Well, that, and the dashboard probably doesn't have anything. And what do we have here? Yeah, this is kind of interesting. You can send raw, these are the HTML searches. Oh, I'm pointing at the place. But down here where it says get, and you can type in the raw searches and get the results. Actually, that'll probably work. So I just get everything. So this can be used to debug your code if you want. And then Kevin's going to talk about configuring ElasticSearch in co-op.
Okay, can you hear me, or is it well enough? Okay, yeah, so like we said, we started with 1711, so we kind of hacked the little things to get ElasticSearch to work, but it's pretty similar to how it is now in 1905. And so here in the administration page, there's an option where you can have an installation, and the options for the search engine. And here you define the fields that will be available. And like he mentioned, so there's a name, a label, and there's a type for common types. And then as he mentioned, there's weighting. So you can weight these.
Can you increase the size a bit? Can
The
you?
size, yeah. So, bigger and small. You can actually read it. So yeah, so there's name, labels, and types. So if you have common, you have strings or numbers and data. Sorry about that. I'll just hold it. Yeah, okay. No one hurt their ears or anything? You okay? Yeah.
Sorry.
Yeah, so like you can have common rules, like you can have a, for ElasticSearch you create a mapping and how the data is handled. And so you can have common types. And there's weighting, and it's actually kind of nice. The weighting is done when you do the query. So like he said, if you want to change, like, oh, the weighting's not quite right, you just change it here, and when they do the next query, it will be active. You don't have to re-index or anything like that. So it's really quite convenient. And then, like you mentioned, there's bibliographies and authority records. And here's where you actually do the mapping. So you have the search fields here. And then as he mentioned, you can make them sortable. You can have facets if you wanted to filter the results at the end. And you can even have suggestions as you're typing. And here's the actual mark fields where you define where the information, when it looks at a mark record, it indexes it. It looks at each of these records and takes that information and indexes it in that field. And so there's quite a few of them. And that is actually one of the issues we're working at right now is we can weight titles, because people, when they look for a title, they want to find it. There's alternatives. Maybe I'll go to production.
We can do a search on the page.
Okay, well anyways, my point's not made here, but, so we have some trouble. Have you noticed there's a lot of fields getting mapped to lots of different mark labels. And so one of the problems is we want to weight maybe different fields differently. So if you have like a uniform title, or if you just have like a table of contents that gets mapped to titles, you don't want to get in the same way. So one thing we're looking at is maybe having a little more granular field names. And then when you search for title, you search all of them. But if you want something more specific, or if you want to weight the uniform title higher, you can do that. And yeah, and it's similar for the authority records. And it's also nice, we did some things with the searching, or sorting, I mean. If you, so if you get a title that has an article or anything in the catalog that has put in it, you should skip the first part of it. Title here, hopefully it's in there. Oh, here we go. So here we have a title that has an article in the front. And then if you go to the title sort, we actually had a rule to cut that off, to look at the mark record and see if there's an indicator saying to skip the first few characters. It's kind of small. But so anyways, it had the article L in front. And so it's kind of annoying. We noticed when we were sorting, you'd have all these titles kind of come together. So we made a rule to take away, if the catalog put an indicator to take those away. And there was also an issue of when we have different fields, like you have 245 A and B, do you want them separate or do you want them as a string? And we had people complaining that they were actually searching for phrases that go across the A and the B. And so we decided to put them together so that you could actually search as a phrase.
So the subfield thing.
Yeah. I think. This. All right. That's it. I'm sure you all know the subtitle of All Our Twists, or The Parish Boy's Progress. And so now it's searchable like that. It's a we were put together. Yeah, so it takes the two fields and puts them together. I think I've been looking at 19. There's an option when you make the actual definition. You can say in parentheses, I think, if you want them together, or if you want to treat it as separately. If you have a whole bunch of fields that you want, actually, like you can see the place facet here, or maybe you can see, make it bigger. So like here, the place, you don't really want to have Raleigh, North Carolina, and Boulder, Colorado on the same line. You want them as a list. But here, it was kind of, people seem to like to be able to search as a phrase. So we put those together. And what other issues? We had trouble, with, there's certain reserved characters like colons you use to specify the field. And it comes up in Swedish a lot where you use a colon in the middle of a word. So we escaped those. And, that's basically what I have. If anyone has any questions.
Och vi kan ju säga, det går ju bra att ställa frågor både på engelska och på svenska.
Ja, det går. Det går bra. Okay. Oh.
Question.
Was the maybe you haven't worked with smaller libraries, but what do you think there is a big gain for a smaller library, mid-sized like Carnes University, to use ElasticSearch instead of Zebra?
Okay.
Just
Yeah.
speed-wise.
I've actually compared them, but it's a very powerful engine. I think it has pretty good speed. It has a lot of nice features. But I'm not sure if it's the features that are more attractive than the speed. I'm not sure about the numbers on that.
But you can have like. I talked to an ElasticSearch expert about configuring ElasticSearch because we have a system. We have 5 servers running ElasticSearch in a distributed system. So we have 2 clients, they're called, the front end, that do aggregations, and then behind them we have 3 workers, and we only have like 2.5 million records. So the guy said that was way overkill. We only needed 1 ElasticSearch machine to do that.
We have 30.
Yeah. So, but it is very fast. But if you don't have a lot of record, I don't know so much about Zebra. That's the problem. So it's hard for me to compare. But yeah, it can handle really lots. I mean, like Google and people use it for this.
But it's the search engine that Koa will be using for, so I guess. So.
But yeah, I don't. I mean, it's fairly easy to install, and then Kevin showed you just really quickly. You just go into the configuration, and you switch. You say not Zebra, ElasticSearch, and you tell it where it is, and it seems to just then you index it. It should work.
It should work.
Yeah, as long as you have a newer version of Kuba. So yeah, I don't know.
I'll use the test server.
Yeah. Sorry. And then any other questions? Or is there no more time or so?
2 minutes. 2 minutes.
2 minutes?
Ja. Fråga här.